So hello guys, in this video I am going to discuss to you what is transmission lines. So by the way, I am Janine J. Panganiban, PSECE 3B. So this is our project 1 for ECE 42. So let's get started. So first, what is transmission lines? So transmission lines are the conductors that serve as a path for transmitting or sending electrical waves or energy through them. So this basically forms a connection between transmitter and receiver in order to permit signal transmission. So as we all know, in the word transmit, so the transmission lines transmit an energy or electrical waves through their designated destination. So it transmit or send an electrical waves through their designated destination. So transmission lines basically forms a connection between the transmitter and the receiver. So it will transmit an energy and it will receive by a receiver. So that will permit a signal transmission. So transmission lines in microwave engineering are known as distributed parameter networks. So again, in the word transmit, we all know that it sends an energy. So in the word sends or transmit, it distributes a parameter or a networks or a signal. So as their voltage and current shows variation over its entire length, it enables the transfer of electrical signals by a pair of conducting wires that are separated from each other by a dielectric medium, which is usually air. So so transmission lines, it can enable to transfer electrical signals. It is because of a pair of conducting wires that are separated from each other. So it is by the electric medium, so which is air. So transmission lines send electrical waves through the destination. So next we are going to discuss, as you can see, this is the example of transmission lines. So next we are going to discuss the figure below. So there's a figure below represents the equivalent circuit diagram of a transmission lines. So as you can see, this is the equivalent circuit representation of transmission lines. So here, the two conducting wires have a certain length and the parameters of the transmission line is distributed over all its length. So these parameters are R, L, C, and the G. So which we will discuss in detail in the upcoming. So the two conducting wires, due to separation, it holds some capacitance, the C, but this dielectric medium does not provide complete insulation. So hence some leakage, or sometimes there's a leakage current that flows through it. So sometimes there's a leakage that happened in this transmission. So telephone lines and electricity supply lines are some examples of transmission lines. So next is we are going to talk about the types of transmission lines. So transmission lines are majorly classified into three categories. So we have the open wire line, the coaxial cable line, and the waveguides. So in these three majorly classified categories, the coaxial cable line are most used or most well known in this transmission line. So we will discuss first what is open wire transmission line. So open wire transmission line, these are the conductors having two lines or two wires. So this is the line or the wires. So it is separated by the electric medium, whose one is connected to the source, while the other one is connected to the destination. So these are sometimes low cost and simplest form of transmission line. But their installation cost is somewhat higher, as well as its maintenance sometimes becomes difficult due to the change in atmospheric conditions. So, open wire line is made up of two wire conductors or two wires that the other one is connected to the source while the other one is connected to their destinations. So next we are going to discuss about the coaxial cable lines. So coaxial cable lines these lines are formed when a conducting wire is coaxially inserted inside another hollow conductor. So these are termed as coaxial, as the two conductors share the same axis. So as usually you can see coaxial mostly in televisions, because coaxial used for television to send a signal for your TV, in order for your TV to have a signal and to have a clear display. So these are widely used, like what I said earlier. This is well known or mostly used in the three categories. So these are widely used in applications where high voltage voltage levels are needed. So that is coaxial cable lines. So next we are going to discuss rectangular waveguides. Rectangular or waveguides, this category of the transmission line is used for signal transmission at microwave frequencies. And these are basically hollow conducting tubes, as they somewhat resemble like coaxial. So waveguides are sometimes, or they are also resembled as coaxial, but they are just different in like I said, this is for the rectangular shape, while the coaxial is for the circle. So, but actually, and also in coaxial, it has a center which uses for you to insert. And but this waveguides, it has nothing in the center. So so that is waveguides. So next is the parameters of the transmission lines. So first we have four parameters of the resistance transmission lines. So we have the resistance, we have the capacitance, inductance, and the conductance. So first I am going to discuss you the resistance. So during signal transmission through a conductor, it is necessary to have an idea about the parameters associated with it. So like I said, basically there are four parameters exist related to the transmission lines. So first is the resistance. So the resistance, this parameter of any transmission line relies on the cross-sectional area of the conducting material. So as we have already discussed that these are distributed parameter networks, that means its parameters are distributed uniformly along the entire length. And also resistance, it is represented by R, and its unit is ohms per unit length of the conductor. So it's given by R, is equals to P times L over A, which P here, or the P here, denotes the conductivity of the conducting material. L here, or the L, denotes the length of the transmission line, and the A, it denotes the cross-sectional area of the line. So it is noteworthy here that the resistance shows the variation with temperature and signal frequency applied to it. So next is the capacitance. Okay, capacitance. So capacitance, as we have already discussed, that a transmission line is composed of two parallel conducting wire separated by dielectric material. So it behaves as a parallel plate capacitor. So capacitance behave or act as a parallel plate capacitor. So thus, it has some capacitance which is also distributed uniformly over its length. So capacitance is measured in farads per unit length of the conductor. So next is the inductance. So this is the example of inductance. So inductance, when current flows through a conductor, then it generates a magnetic field perpendicular to the direction of the electric field. As the magnetic field varies, electromagnetic flux gets generated in the line. So this EMF now flows in opposite direction with the current flowing through the device, which is known as the inductance. So many of us know what is inductance, right? So we can mostly see this inductance. And its value also depends on the current flowing through the conductor. So this one is the current that flows through the inductance. So the value depends on the flow of the current. So inductance is also represented by L. So like I said, in the circuit diagram that represented in transmission line earlier that I discussed to you. So the parameters are represented by the R, L, G, and the C. So L is the inductance or the length. So it is represented by L, and its unit is Henry per unit length of the conductor. So last is we have the conductance. So conductance, the two parallel conductors are separated by a dielectric medium, but it is not a perfect insulator. So conductance doesn't mean it is always performed in a complete or a perfect insulator. So due to which some current also flows through the dielectric, this current is called the leakage current. So it conducts, that's why sometimes it is called the leakage current, and it is responsible for the leakage that sometimes happen in the transmission lines. So conductance through the transmission line, it is basically between the conducting wires and is represented by G. So its unit is MHO, megahertz megahertz per unit length of the conductor. So the four parameters of the transmission lines are represented as R, L, C, and the G. So we already finished discuss the parameters of the transmission lines. So next we are going to discuss, or either I am going to discuss to you the properties of transmission line. So transmission line that allows a transmission line that allows the propagation of electrical waves is assumed to be uniform as well as symmetrical or aligned or the same in nature, so as to have a convenient transmission. The properties of transmission line must be uniform or must be the same. So basically there exists two electrical properties of any symmetrical network. So first is the character impedance, or the Z sub O. So suppose an electrical wave is traveling from one end to another through a uniform as well as a lossless transmission line. Then the ratio of voltage corresponding to the transmission line and the equivalent current that is flowing through it is known as characteristic impedance. So it is to be noted here that no reflection of the transmitted wave will take place. So it is given by Z sub O is equals to square root of voltage of transmitted wave divided by current of transmitted wave. So in terms of parameters, characteristic impedance is represented as this. So Z sub O is equals to square root of R plus J omega times L divide by G, or the conductance, plus J times omega times the capacitance. So when we consider a completely lossless transmission line, then it is given as the Z sub O is equals to the square root of length, or the resistance, or the inductance, divided by the capacitance. So the symmetrical network is said to be accurately terminated when the characteristic impedance at its both ends is equalized. So next is the propagation constant, or the Y. So propagation constant of a transmission line is defined as the ratio of current achieved at the output to the current applied at the input of the system. It is given as dE raised to Y, or the propagation constant, is equals to I sub O over I sub I. So Y here denotes a complex quantity represented by A plus J times B. So here A is the attenuation constant, and B is the phase constant. So that ends our discussion. So for the transmission of a signal having a high frequency range over short as well as long as distance, so transmission lines are used. So if the transmission lines have a high frequency range for a short distance, so transmission lines are used. And at the same time, this reduce the loss of power during transmission. So these are also used in stub filters, in stub matching technique, and also in voltage transformer. So that's all for today. That's all for our discussion. Thank you for watching.